Hello, it's dumplet here. Here's an item on combinatorics, on sets. How many subsets of the set containing 1, 2, 3, 4 until 10 are there so that it will contain exactly any one element of 1 and 2? As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now here's a clue on the screen. So the sets should look something like this. It should be like 1 and then other elements which does not contain a 2, and then the set containing 2 along with other elements that is not a 1. So let's try to take cases here. So case 1, let's say we have the element 1 and it doesn't really matter all the other elements but excluding 2. Therefore, we can choose any number of elements from the set 3, 4, 5 until 10. Now this is true for the first case. So I can choose 0 from these, I can choose 1 from these, I can choose 2 from these, and I can choose all of them if I want to. So that is equivalent to getting the number of subsets in this set containing 3 to 10. Therefore, all we have to do is just use the formula 2 raised to the number of elements to give us the number of subsets. So 2 raised to, we have 8 elements from 3 to 10. So we have 2 raised to 8 for the first case. So there are 2 raised to 8 subsets that contains only a 1 and not a 2. Now we can do the similar for the second case. If our subset contains 2 and some other numbers, again we can choose 0, we can choose none from these, we can choose 1 from these, we can choose on and on until we can choose everything from these. So that's again equivalent to saying equivalent to getting the number of subsets of this set. So similarly for this case, we would have 2 raised to 8. Now just an example of what I mean. So for example, I have 1 here, and then suppose I will choose 3 and 5 from this set. Then I'll obtain the set 1, 3, and 5. And I'll have my 1 here, and then other elements that is not a 2, and that's going to work. So all the possible cases are covered by the 2 raised to 8 here, and same is the case for this. So all we have to do is just add the 2. 2 raised to 8 plus 2 raised to 8. Now 2 raised to 8 is equal to 256, so 256 plus 256, and we're going to get our final answer of 512. And this will be our final answer. Now, let's take a look at the alternative way to solve this item. Now consider this. In all of the subsets, in all the possible subsets of the given, so the given set 1, 2 until 10, note that every subset will be exactly one of 4 possibilities. It's either the set contains a 1 and doesn't contain a 2, or the set contains a 2 but not a 1, or the set contains both 1 and 2, or the set contains none of 1 and 2. Now this is particularly interesting because note how in each case the rest of the elements it's determined by practically the same thing that we're doing, which was choosing some elements from the set 3 to 10. Now all of these would simply be equal to the number of subsets in each case would be equivalent to solving the number of subsets from 3 to 10, which is, then again, it's still 2 raised to 8. Now, note how the cases that we want in this example is this. It either contains a 1 or a 2. So it's 2 cases out of the 4. So it's 2 over 4. So 2 over 4 over the total number of subsets. So 2/4 times, since there are 10 elements from 1 to 10, the total number of subsets is 2 raised to 10, the number of elements. So simplifying this, we're going to get 1/2 of 1024. And once again, we will be able to get our answer of 512. So this is indeed our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!